Hi, folks. I'm Ronnie Belmans, and I'm going to talk to you a bit about technology, the promises and the reality of things. What is going to be there? Because a lot of people are saying technology will solve everything. We can get to carbon neutral energy supply without any problems. Things will be solved by technology. And if we look at the newspapers, solutions are everywhere. Wind turbines, from small to the gross to giant floating wind farms on the sea. We have PV panels from building facades to gigawatts in the desert. We have batteries with new materials so cars can drive for 2,000 kilometers and further. We have superconductors in the gigawatt size for HVDC. We have carbon capture and storage with turquoise hydrogen. No problem at all. We have nuclear plants with small, uh, medium-sized nuclear reactors. Really, nuclear fusion is there, so there's no problem left, one would think. However, it takes time. And this is a key message I want to bring to you. It takes time to get there. It takes time to get from an idea to a prototype. It gets time to take the selling procedure going on. The energy transformation requires a lot of investments in the grid, in the industry, in transport, in buildings, and that all takes time. Now, if we just look at the RD&D process, the research, development, and deployment, we have what we call the technology readiness levels. It goes from one, the basic principle and ideas. It goes up out of the labs from TRL4 onwards. Then it goes into demonstrations, and then it comes to an actual system proven in operational environment. Now, if you just talk about, say, for instance, a new type of nuclear reactor, this all procedure, these logical steps, make even take decades. But also for a new type of battery, it takes a few years to get there. And then you have a product that can go out of the company. But the product is not sold to everyone in 2 months. It's not a vaccine that comes on the market and everyone wants to have it, but it takes time to customers to buy it, to get it to the innovators, the early adopters, the early majority and the late majority, and then to the laggards, to have everyone going from the internal combustion engine car to the electric vehicle, for instance. So that time is again adding to the TRL level climb up of several years. If we go further and we see then to the energy transformation, we really have all of those elements coming again in each of the lines that we have to distinguish in the whole energy transition. A lot of talk these days about producing hydrogen. Now we do produce hydrogen, gray hydrogen. Gray hydrogen is made out of natural gas with steam methane reforming. This decade, we will try to decarbonize that procedure by capturing the CO2 that comes out of it, which leads to so-called blue hydrogen. But this is not really where we want to end up because it still releases 10 to 15% of CO2. So we have to go to real green hydrogen made by electrolysis using green power, wind or solar. But that is going to be beyond 2030. Otherwise, we don't have enough green power for electric vehicles, heat pumps, etc. So 10 years from now, we may start to think about green hydrogen, not now. And then we have other procedures, other processes which will be there, which, for instance, are the processes based on pyrolysis, often referred to as turquoise hydrogen, which are now in the TRL level, remember the previous picture, of 4 to 5, and still have 10 to 15 years to go to get to the first industrial site and size. So you see, yes, we can produce hydrogen. Yes, we can decarbonize it, but no, it won't be for tomorrow. Technology is still on the move. Solar energy, rooftop PV, that's no problem. And silicon grid size installations are there. This decade, we will see a continuous improvement of efficiency and circularity. Beyond 2030, we will see building integration with new materials, we will see multi-layer PV panels, and we will see a combination of producing electricity at the same time as e-fuels via panels. But again, this is all announced in the newspapers, but it will be 2030 and beyond. In the grid, we will see new things. The transmission grid, HVDC links will flourish this decade, by sure. But beyond 2030, we will see the real overlay grid with DC, with redundancy. We will see integrated storage in the whole system, and we will see integration with other carriers. Distribution grids will see active grid management. We will see beyond 2030 DC in those distribution grids. We will see local grid management, and we will see also control for demand. Resilience and automatic rebuilding of grids will be developed, but again, 10 years from now. So do we have new things to do? Yes, but are there things already there for all of the applications? Not at all. In industry, another example, you see different processes coming along. And energy efficiency and decarbonization may contradict. For instance, if we look at refineries, they will fade away. Why would we have refineries by 2050 when we don't drive in the internal combustion engine cars? So the cars are fading away, going to electric, so the refineries will fade away. So there are totally different industry coming along. Time is very critical. If you look at an industrial process, it only gets a major overhaul every 5 years. So if you want to introduce a new technology, and the overall process has just undergone a big overhaul, you have to wait for another 5, 6 years even to try something new. For instance, to add carbon capture and storage. And if you really want to go to new processes, it goes beyond 2035. For instance, if you want hydrogen-based reduction steel. And transport. If we look at transport, electric cars are ready to go. Infrastructure is needed, but that's all there is. Heavy road transport seems to be ready. There's no technology stops anymore on the route. It's building it, designing it, and go for it. But aviation and navigation are not electrically based for the time being in thinking. We will need ammonia for navigation. The technology is ready. It's based on green hydrogen, and it will be there by 2030. But synthetic fuels requiring CO2, for instance, if you want to use methanol for flying, or if you want to use methane for shipping, these are things that still have to be built on, still have to be developed. So 2030, 2035 and beyond. In buildings, we have an innovation wave, but buildings are very conservative. It's very time and consuming and money consuming. It's expensive. The technologies are present. Financial is critical there. The comfort for the persons living or working in the buildings has to be a constant concern in the energy transition. And we have to go to a number of buildings together, what is generally called local energy communities, and we will see a combination of electricity and heat. And then, step by step, with the renovation wave, we'll be getting there. The set plan. is the big plan of the Commission to get there. And the SET plan, Strategic Energy Technology Plan, has a number of chapters. And if you look at the funding, you see that it's very difficult to understand where the major emphasis lies. And those emphases explained by the number of euros invested in it is not coherent with what is to be expected. If you look at nuclear safety, there's almost 6,000 million euro involved in it, and really it is no investment in new things. So have a very good look at this and have a look at it in the sense of all the elements that I announced you. The coherence between what has to be done for decarbonization and the set plan is rather low. And if you look at the set plan, they also define TRL levels. And you see that an awful lot of those TRL levels are still on top, so are still in very low TRL levels. All those things which are in the top left corner won't contribute to anything this decade. Maybe the bottom left ones can contribute by the end of this decade. So, more about networking. All of those elements in the set plan are now getting to be networked. System integration will be key. And that, ladies and gentlemen, comes to my conclusions. Time is critical. Time to develop, time to bring to the consumer, time to get it installed in buildings and industry and grid. We have seen the TRL levels in the set plan, and towards 2030, there will be nothing that is not out of the R&D now that will give a substantial contribution towards the minus 55% Green Deal target. So don't think that what you read in the newspaper of the big element which was found in the laboratory will change the world to get to minus 55%. That will be done by present technology that is already out of the labs and ready to go to the shelves. I thank you for your attention and good luck. Have fun with the course. Unfortunately, it won't be in Firenze itself because that marvelous city, we cannot get there. See you.